I think I've talked enough.
All
I've
right.
already talked too long. I'm going to hand it over to Rich. We're going to spotlight him and I'm going to go cams off. But hey, I just want to say thank you for joining. We're really excited about today.
All right. So I'm gonna go ahead and share my screen, and let's get rocking. So, welcome to the first of many webinars that we intend to do over the next couple of months, which is all about showing everybody what we're doing with Ozone. So today, it's an introduction to Ozone, and really that's the goal of this series is to not only explain the technology, what Ozone is, but also how to use it, both from a rigging and an animation and a pipeline point of view, how to take advantage of what we believe is a better way of building and deploying characters in production. We'll also have special guests throughout the series, other companies and other software packages that work along with us, so we can really show how Ozone can solve real problems in the real world. Today, we're going to cover a very basic what is Ozone. If you've seen my demos at Unreal Fest and other places, it's going to seem very familiar, but I wanted to capture that baseline of what is Ozone now, what have we done, where have we come from, and then lead into where we're heading or where we're going. Then I'm going to talk about how to author in Ozone. So we're going to do a very basic tour of the new UI in Maya, show how authoring works, both weighting, fitting, and sculpting today. And then, of course, we'll get into more depth in future webinars and then Q&A. So if anybody has any questions or interested in knowing a little bit more about what we've talked about, we'll get into it. All right. So let's go ahead and jump right into the demo. So this is a test character of ours. We call her Zoe. And I always like to start here with this little test character to point out a couple of things. The first is that Ozone is driving this character inside of Unreal directly. This is not an Alembic cache. This is not a skeletal mesh. This is not an FBX. This is an Ozone asset being driven by the Ozone plugin directly inside of Unreal. Another thing, which we'll talk about a little bit later, is that there are no joints or blend shapes in this face. So we have a different way of approaching that. So let me select her now. Because we control this stack top to bottom, it allowed us to implement real-time subdivision surfaces. So now your rigging artists can be dealing with that many points, and at render time, you can have that many points. So right from the very beginning, let me go ahead and zoom in here. We'll take a look at this a little closer. What we're trying to do is create a solution for artists solving real problems right away. And when a rigging artist can handle and deal with this many points versus this many points, it means that it's easier to make changes. It's easier to take art direction. Everything about the workflow, even the data size, bringing stuff to and from Maya to Unreal or any other environment gets much, much easier. And in a way, it gives us resolution independence, right? When we look at this, you're seeing perfectly smooth results in Engine here, and you don't have to pay the price for all those polygons and managing all those vertices. Okay, so this little animation here was actually done in Maya, and it was brought down into Unreal. So let me show you another example of that. So we have this little puppy animation. All right, have here. So same thing. We got a little character authored in Ozone. It lives in both Maya and Unreal exactly the same, and I'll show that over in Maya here in just a second. And this animation is brought down using our clip system. Now, this is a very virtual production type, point of view. When we think about this, right now we have our blueprint, which represents our plugin. We have our asset, which controls, or not controls, but identifies all of the weighting, all the fitting, and it basically describes the character. You put these two together, you drop them into Unreal, and you have an asset that's ready to be animated. Like I mentioned, this demo is kind of geared toward virtual production, but at this moment with this character, we could attach a control rig to it, and we could animate directly in Unreal and not need Maya at all. Right? It's a live asset that's ready for animation. Now, what we've shown here, though, is animation coming from Maya. And what we're doing is we're using our animation clip format. Now, what is that? So if we think of this, normally, if you're trying to bring a complex deformation system out of Maya or anywhere into Unreal, you use an Alembic. An Alembic cache is a way of taking every vertex in the mesh, storing it at every frame, and really caching all of the geometry so that you get a pixel perfect result on the back end. So we did a test. This little animation of this pup is about, oh, 30 seconds long. And as in Alembic, it's 265 megabytes for this. Our clip format, it's only 13 megabytes. So now you get exact perfect animation results from one system into another, in this case, Unreal, and it's 90% smaller. So for the virtual production pipeline, right, people that are animating in Maya and using Unreal for rendering, now you can send your animation down into Engine much, much faster. Load times are quicker, file sizes are smaller. It's a real win across the board for that, right? Now let's look at this same asset in Maya. So here we are, and I'm using an off-the-shelf puppeting system, M-Gear. Thanks, Miguel. And what we're doing is I'm using standard Maya joints and IK and everything else, but the deformers, the deformations are all Ozone. So what we've done is we've taken the Maya skin weights and we've taken those away, and we're bringing Ozone and connecting it to this scaffold, if you will, this puppet. What this looks like in Maya is that we have an Ozone node, which, as far as Maya is concerned, is just another deformer. So we play incredibly nicely inside of this environment. Where it's different is that the entire deformation system of this character is expressed in this single node, right? So everything down here is every input that would go in to drive a deformation inside this character. If it's a joint, it's a matrix input. If it's a channel, we'll show you here, like on the mouth, but this is a float channel. And what this means, in a very practical way, is that in this case, this M-Gear puppet, it all lives here on the left, and all of its data just wires into our node. So now you can take right at the beginning, this idea means a much smaller footprint in Maya, far fewer nodes in Maya. So your execution speeds are much faster. More importantly than that, though, for all my animation friends out there, is that none of your animation controls have to change. All of your toolbox, everything you use for, if we're talking about Animbot, if we're talking about custom controllers, pickers, whatever, all of that stays the same. And then your TDs just do a little bit of glue to connect the output of that animation control into our input of the rig control, and you're off to the races. And this is a very big deal for us. So that Ozone becomes a very friendly addition to a pipeline, and doesn't mean you have to replace everything. If you do decide to replace everything with Ozone, you don't have to change your animation system. So animators continue to work. They just get faster characters with better shapes that are more controllable. Okay, so now that we've kind of shown that, if we think about this a little bit, what it means is, because Ozone is a general deformation solution, and we control the deformations from top to bottom, this means that we can expand the deformation toolbox, right? Typically, you are limited to joints and blend shapes. We call that the two-hammer toolbox. And that is what you would bring out of Maya into Unreal, right? Anytime you're going into a game engine, or any kind of interchange, most often, you have to go down to the lowest common denominator to be able to get that interchange. With Ozone, there is none of that. There is no compromise. All the different deformers and deformations that we support work everywhere Ozone has been poured in. Now, this means too that it's a company of rigging artists. So you've got, the rigging TDs running the roost here at the company, which means that we were able to look at something like, in this case, an arm, right? A wrist and a joint solver, if you will, and try to make something basic like a joint better. And, let me illustrate this in a real way, right? If we think about how a wrist works, right? You have your FB, you have your LR, and then when you do your twist, right? The weighting appears different. You have to average that rotation down the arm. Now, in a traditional setup, you have a joint here, and then you have a joint right up underneath it, right? And then at least one, if not two joints down the arm. So to get this, averaged result, and you think about a shoulder, you're looking at 6, 9, 12 joints. With Ozone, you can have separate weight maps for each axis of rotation. So what you're looking at here is a single joint with 3 weight maps, right? And no blend shapes, right? We think about a shoulder. Same idea, right? We're solving this problem by having different weight maps for each axis of rotation. And what this does is it helps solve the shoulder, wrists, hips, and ankle problem that every bipedal or quadrupedal character has to solve. And because we've been doing this as long as we have, we've put a lot of time and effort into make the basics, in this case, a joint, even easier. Now, it also allows us, like I said, to expand the deformation toolbox, right? So here I have a joint on the head. You open up the ozone panel, right? And what I'm going to do is I'm going to animate the mouth opening, right? So here I'm taking the jaw and I'm opening it down. Now, what's different about this is that this is a single curve. We've authored this curve, and then we're sliding the mouth down along that curve. If we look at the front part of the face here, right, I can adjust this left and right. That's another curve that's doing left and right. Now, the takeaway here is that if we look at this entire front part of the face for this little creature, we've rigged it with two deformers, just two deformers. There aren't a string of pearls and all over here. There's not, joints all over the place and managing this huge substructure. We're able to do a lot more on the surface with a lot less rigging, right? Now, the tail is another example of this. And I've got a joint at the base, but the tail itself is, I'm using a parametric bend. So instead of a line of joints that are running down here that I'm managing weights, it's a single line with a single weight map. And everything you're seeing here, slides on curves, parametric bends, joints, everything else are all playing nicely together, right? And that's because of the way our system is designed. And we'll get a little bit more into that as we go forward. But to take this sort of to the next level, or in our case, sort of a little science project, we have this little example here, right? So here is a magic carpet. This little example is done with 9 deformers. There are no joints, there are no blend shapes in this little example you're seeing here. And for anybody that rigs anything, think about how hard this kind of character would be to develop using just joints and blend shapes, right? And everything you're seeing here is running incredibly fast because we're dealing with less deformers to create these complex shapes, right? Okay, so let's go back into Maya here and I'll load this rig up. We'll talk a little bit about how it works. So we'll go and open up our carpet. All right. All right. So we have our carpet. Let's open up our panel. So let's look at this and see how it's designed. Now, the way Ozone works is that we are an order of operations based system. What does that mean? That means that every deformer sits in a stack and they execute in order. One goes, then the next goes up the chain. Every deformer can have its own weight map. So each deformer can have its own weighting and they add together. It's an additive system. And we can also animate the weight. So we can take that one unique weight map for that one deformer and dynamically change those weight values to create custom effects, right? So from a how the system works point of view. Now let's look at it in the context of our little carpet here, right? So here is, a little curl at the front. I can tighten this up to make that look more appealing. I can come back here, curl this up. I can tighten that up, make that look more appealing there, right? Looks like a little parchment. But because we're dealing with an ordered system and all of those deformers remain live, I can do things like this, where I can shift the carpet through the curl spaces. So what I'm doing here is I'm executing a translate, in this case, in the Z, pushing it through where the curls activate, and it does this kind of thing. And again, I want you to think about how hard this would be in your traditional joint and blend shape based setup. All right, now let's talk about animated weights and how do we show this? We look here, I can add a ripple, right? So we look at this. Now what this is a single translate pushing upward, and then I'm attenuating the weight map by a sine wave. Because I'm using this sine wave, I can animate the sine wave. So now if I do this and I move it, right, it looks like the carpet is flowing. And everything you're seeing here with this ripple is, again, one deformer. I'm able to take one single translate, and by animating how those weights work, I get this really nice complex example. Now, if you're noticing, for my animator buddies out there, right, that the front part of the carpet is not affected, right? And that's because I can carve out or subtract that weight as well. And in this case, I've synced that up to the roll. So here, if I roll this up, you'll see that the ripple is coming away, right, as I do, but it still remains active at the end. So now, from an animation standpoint, you can set this ripple up, create that characteristic, roll the carpet up, it goes away, roll the carpet back out, and it comes back. You're not fighting against the rig, you're not countering animating against anything, and it just kind of flows in and out, right? All right, so that's kind of our three main principles, but let's look at this in the context of something that's a little more, I won't say real because the carpet's real, but let's look at a human character. So here's a little test character of ours that we're using for a short film that we're creating. Short film's called Like. It's directed by Mark Walsh, and we're hoping that we can get that bad boy finished. We've been working on it for a while. All right, so here is our character. Again, I'm using M Gear as a, as an interface into the ozone system. I'm gonna go ahead and we're gonna move these glasses out of the way. We'll come in here, and then I'm gonna use the actual picker from M Gear instead of the ozone interface. And to bring this up again, I'm using these as a picker and I'm going to drive sliders, right? In case, the brow here, all of this could be done with pickable things on the surface with different face pickers. It's up to your company and your personal taste as an animator with what kind of controls you want. You just have to connect them into Ozone with a little bit of translation and you're off to the races. Okay. So this brow here, right, actually is a slide on a curve. We're actually sliding up and down the brow. It's a single deformer, right, that's coming down here. But all of the shaping for this brow, in this case, I'm doing the mid, I'm doing the in. What I'm doing there is I'm animating the weights of that deformer to create these complex, in this case, intricate shapes. Again, I'm doing far more on my surface than I'm doing with rigging under the hood. And we'll talk about this here on the second part of the demo too. All right, let's grab our this. We can, I can pull the eyelids up and down. I can shift them left and right. We have a mouth corner here. Actually, let's do this instead. We can lift the mouth itself up and down. I can go left and right. If I want, I can twist it. Right. And then the nose, if I want to line the action from the brow down to the lip, I can use a bend. So now I'm bending the nose over so that your line of action, right, you're arcing down into your mouth. Each one of these the mouth corner has two deformers, a left and right and an up and down. Each one of those is separate, right? And then when I come to the jaw and open it, right, it's its own idea. Now, in all of these cases, each one of those deformers has its own weight map and they all layer on top of each other and they add together. Now, what this means is I can broaden the effect of any one deformer and I'm not worried about fighting against all the rest of the stuff in the rig. So if we look at the jaw, right, and I come up here and I look at the temple, when I mung this up and down, right, you're seeing little tiny movements all the way up into the temple. I mean, really, you can see these points are moving. And that's because of that weight map feathering or fall off. It can be so much more broad, which means that in the case of animating this character, any of these channels is going to bring your surface to life because you're not localized. You're not dealing with zones of action that are sitting there. It can feather out and keep that surface alive with your animation. If we look at the lip here, right, same idea that we did on the brow. It's one deformer, but I'm animating the weights to get like these tiny little controls, right? And everything you see here, everything that's running in Maya runs exactly the same anywhere Ozone has been ported. In this case, I'm going to show it to you running in Unreal. Let's bring this guy up here. All right. So now we have our character. Oh, boom. All right. Well, give me a second to reset because thank you, Windows.
They say we could cue up the Jeopardy music.
There you
I've
go.
got it here on
Thank you.
standby.
Thank you, Windows, for a recorded webinar. We'll get it going again.
Uh, it's funny. Hey, well, some questions are
Funny.
coming in. Yeah,
Funny.
that quote. Questions are coming in. We're going to do our best to answer them as Rich is going. And then I've got a few questions that I thought might be good for everyone who's joining the webinar to hear, kind of queued up at the end here, Rich, too. So we'll still get that 15 minutes of time after your continued demo here. But
No,
be on the
it's just
lookout for answers along the way.
waiting for it to do its business. Give me 1 second. Yeah, go ahead and answer questions while I'm firing everything back up. Yay!
All right, well, here's one of the things that popped up that I wanted to make sure we covered. Can I use Ozone characters with mocap or motion capture? And
Brad.
yeah, Brad, take us away, man.
Yeah, so you can, as long as you saw the M gear rig driving our Ozone deformer node. So any skeleton input that you can map mocap to with HIK in Maya or in Unreal through LiveLink or any other source that you can map to a skeleton, then you can drive the Ozone character with. So yes, you can.
And we've done it, and we've done
And
a
we've
lot of
done it
it.
live at SIGGRAPH with Vicon and House of Moves, so that was great.
Yep, we'll show. All right, I'm good to
Yep,
go.
you're
And
back.
we can get back
All
into
right.
it. Yeah. Again, nothing like getting a. Hey, everybody! If Windows decides to update your machine the night before, or turn that off.
Sorry, Rich. That's funny.
Oh, it's not anybody's fault but my own. All
All
right.
right, jump back in, bro. See you.
To where we're looking at here is that same character running here in Unreal. And the key takeaway is that this is live, right? This is a live system. We're running with Ozone here. And you get all the dynamic action that we showed before. And you basically get something that looks as good as it could, as a feature animation final rendering out of a standalone renderer right in the game engine, right? And everything we're seeing is live, right? So if I come in here and I go to, say, the jaw, I can open this up and it will work. And it will allow me to edit, right? So I can edit these guys and move through, which is great. Here, let's look at another animation. And we'll bring this up. I didn't restart the PC, so we'll see if Windows decides to be a jerky jerk when it does stuff here. So we'll go. So here is that same character, but running through. And again, I mean the key thing is it's live, it's real time, and it gives you the kind of results you'd expect, with a high quality final renderer out of a standard renderer in this case. And you'll see we're driving Groom, we're doing all kinds of fun stuff here. Now, the very first like real engagement that we did was with the fine folks at Real Effects. They were developing a show called Supergiant Robot Brothers. It was directed by Mark Andrews. And we engaged with them early on to bring Ozone into their pipeline. And what that did for them, or let's get into some specs. That show, let's double click here. That show was 10 episodes, 5,000 shots, 150 characters, and it was all Ozone. So it was our real like trial by fire in production. Now, the wins of this turned out to be really, really significant for Real Effects. Their animators were generating between 20 and 30% more animation per week because the characters run fast not only in Unreal, but they run fast in Maya. So it means they were not slowing down for basically the rigs were not getting in their way. They never had a load time in Unreal, which they did all their lighting and rendering in, that took longer than 90 seconds. So the file sizes are smaller, the load times are faster, and animators are working quicker. So it was a real win for them. They were able to produce that show in a well within their budget, which was great. Here, you'll hear some audio when I play this.
That's a Roger. Twister, Obliterator, activated! The juice sir, are chunky.
Again, this is real geometry and it's just shaded like cartoon.
You were right this whole time. I'm a gorgeous failure. A red hot nothing.
And I think one thing I try to point out, with this part in the demo is just the diversity of the types of characters that we have rigged with Ozone, that you can rig with Ozone. We are not a one-trick pony. And I don't even mean that in a negative. You look at something like MetaHuman, which does what it does really, really well, but it does what it does, right? It's for bringing photoreal people onto the screen. We did creatures and we do monsters and we can do Lego people. Let me hit play here. Just hear me talk, right? We can do robots. We can build cars and mechs, and like Ozone is a general rigging solution. And then we build components like a mouth rig, a lip rig, and whatever, and we deliver those components to our customers. Not that you can't build your own, but we give you every rig that we have shown, we give you the components so that you can use them and start not at zero, but at something is going to work and work well, and we're going to teach you how to use it. Now, what's fun about this little guy here is, again, from a how can we be a little different or show some diversity, is that this face rig here is actually a 2D face rig, right? Or sorry, it's a 3D face rig that we are pushing into this 2D space. So we have a camera off to the side that's an orthographic camera that's rendering a texture and live putting it into the UDIM. What that means, though, is everything I can manipulate. It's still a 3D rig, right? So let's go here, right? This means that I can pull and adjust this brow, right? I can move it left and right. I can adjust its scale. I can twist things around here. I can, pull these guys up, and you see it's all working. It's all live because it's geometric elements using deformers to then create this texture. Now, one of the big wins of this is that now you can have a repeatable, reusable, and adaptable rig because we don't normalize our deformers, right? And the deformers are additive. And again, we'll show that here in a minute. But the animation is, that means that when you open a mouth or you move a brow, we can give animators a value that means the same thing artistically across any number of characters, so that you can then, well, here, let me zoom this out so you can watch it play. Right? That you can build an animation library and more effectively reuse that animation library across any number of characters, because you're going to get consistent results from one character to the next, whether it's a giant monster that's a mile tall, tiny little mouse running around on the ground. The rigs will be similar. Now, there's never a free lunch. You don't get 100% reuse, but if you can get 80% and build a library that can be reused for phonemes and speech and everything else, and start at 80, it's a huge win for a studio in their production. Anyway, that is the basic demo there. Let me fire up some stuff, and we'll take a look now at how you do some authoring inside of Ozone. Come on, MCs, now's the time where you're supposed to do something.
So are we supposed to cue up the Jeopardy music again?
Yeah. So because of the Windows anomaly, I really should reboot this machine. So is it okay for me to jump in and out of this and you guys answer questions? Yeah. So give me 1 second, because I don't want to show this with wacky driver insanity. So give me 1 second, everybody. Hey, nothing like jumping off stage and coming right back during a live demo.
Exit stage left.
All good.
I'll be right back.
Hey, real fast though, we've been having a lot of people ask questions, and keep asking them. Brad and I are answering some in the chat when we see them. Well, I'll use this moment too, just as a quick reminder that we're live streaming on YouTube. That's new for us, Ozone as an organization. But if you want to go send some support, jump over there and hit subscribe.
Or share it out if you want. That's good too.
Yeah.
One question, I think. Yeah, go ahead, Kai. Sorry.
Well, just as I was going to say, Brad, and we'll jump into a few of those, but share it out. This is only our second webinar. We have a whole nother set of training things that will go deeper into certain areas of what Rich has talked about today. And those are coming. So be on the lookout. We'll send out some emails about those things, different stuff yet. But question number one that we've been asked several times now, and I feel like we just have to address it. Houdini. When are we going into Houdini and why? We're not quite in Houdini yet, but we do have it on our 2025 roadmap. There's been some talks about moving it up or moving it out, kind of based on client need right now. And so the more that you guys ask about Houdini and its relevance, the higher it will bump up for our
Yes.
development roadmap. And then Brad, go ahead, jump in if you had
I
another
was just gonna
question.
say, so I think sometimes the Houdini question comes up, but right now, if you're using Houdini for effects or groom or hair or whatever, the ozone deformer in Maya is a deformer, so you can still cache the mesh out or save the mesh to Houdini and do stuff to it as a base model, and then send it to Unreal, which is how it's been being used with some clients, and then it's just a deformer as far as Maya knows, so you can mix it and match it and still get stuff out without it being in Houdini Live yet. So that's one thing to keep in mind. There was also another question from David about does Ozone do shading rigs, and I'm not quite sure what the rig would be, but I'll just explain that, like, the deformer rig system contains the geometry and the deformation, so what the final shape looks like, and the processing of the mesh for sub-Ds in Unreal is there. All the other shading and connections or anything that's outside of a where the point lives, that is still standard workflow. Our node contains shader links, so when you open it in Unreal, those things are there you can attach to. So if you're doing some kind of vein or normal map or something that's tied to blood flow or whatever, those would just be driven by our attributes, and you'd still treat the shading and workflow the same you would have in your existing pipeline. So we don't handle that internally. We do have our sculpt mesh stuff. So that if the point is in this position, that's us, and then everything else is standard workflow tools. So hopefully that answers your question, Dave.
Right on. All right, well, here, while Rich is still rebooting, I'll have to shamelessly use this moment for a quick little plug. On those webinars that we're going to be doing in the future, we're going to have a lot of guests coming in and joining us. Names like Jason Bickerstaff, Jason Davies, Brian Tyndall, several, and even Brad himself, kind of featured at some expose where we talk about some of the work that they've done in the past, how they're using Ozone today, and where we see Ozone going in the future. So we're really excited about those. Be on the lookout for those. Those are going to be, I really believe those are going to draw a larger crowd or real big audience. So make sure you are on the lookout for that. And it looks like we've got Rich.
Sorry.
Rich loves when I call
I just
him
didn't
Brad.
want to walk into giving a demo with hardware that was in a janky state. So at least we'll have a fresh thing here. And again, be careful when you do your Windows updates, especially when you got a live webinar.
Hey, it worked out. Brad and I were able to tackle a couple of questions. We'll continue to do
Cool.
that in the chat. But now that you're back, Rich,
Yeah.
are you
so
ready?
Now,
take us away.
Basically, it's honestly, it's part 2 of the demo. I'm going to show you authoring elements inside of our tool inside of Maya. So yeah, we're going to look at the Ozone editor and how we made things.
And real quick, while you bring that up, I gotta just shout out Vanessa. We've had a lot of partnerships and great partnerships. Vanessa's in the chat with Jolly, and they're just great organization we love partnering with. And there's lots of different ones that we're going to feature in Spotlight over the next few months.
So. One thing, and if you guys want to check it out, if you want to put the link for the Anim Revolution website, we've actually partnered with a bunch of different companies to show, and everybody works independent of each other and works well together. And it's really what a real pipeline is like when you're really trying to solve a problem. It's not like you have just one application on your computer when you're trying to build anything. You've got all kinds of, you've got rig systems, you've got animation systems, you've got rendering systems, and some tools are better than others for very specific tasks. So having a pipeline where you can work effectively across all these multiple applications is really valuable. So we really want to show that in a real way. So we will be bringing partners in and talking about how, from our point of view, how we use Ozone in this case, like talking to Vanessa or the guys over at Jolly. you know, how House of Moves can work with mocap, how we're dealing with, you know, all of these companies. So anyway, expect that in some of these webinars as I talk with my hands. All right, so let's get right to it. All right, so let's look at this here. Okay. So here is that little sample character, right? And here it is running inside of Maya. And then we have our Ozone editor. So if we think about Ozone being a standalone, you know, a self-contained rigging system, right? What this means is that our assets have all of everything you need for that character to be deformed. It lives inside it. Think of our editor as a window into that file. So now we can go in and get data out, and we can push data back in, and we can manipulate everything we need so that we can then package it all up, make a portable, reusable thing that can be dropped into any other environment we have our plugin. So let's just start right away here. So I'm going to go and we're going to look at the different modules. So if we look at this, right, here are the modules I was talking about. We have a brow module, lids, wink, jaw. So all of these different components have been designed to work well together and give you consistent, repeatable results. Each one of these modules comes along with our rig library as when you get the Ozone license. And they're all designed and organized in a way. So green is like animation channels. This yellow color is fitting elements. Blue is weighting, and this red is sculpts. And then those are the key things, right? You're animating values. You're adjusting the fitment of things, whether it's where a joint's rotation is or sliding along a curve. Weights maps, obviously, is the weighting of that deformer. And then sculpts, that's our word for a blend shape correct. And we don't like to use the word correct because really, when you think about the way current rigs are set up, 80% of the shapes are blend shapes, right? 80% of the movement you're seeing is hand-authored blend shapes typically, with 20% being joints and deformers. Ozone flips that on its head. 80 to 90% is deformers, whether it's a rotation again or a slide. And then we use a blend shape just to do volume or to tighten up a line or make a very specific result, like, you know, wrinkles on an old man's forehead. But that is a smaller percentage. It's not a correction. It's a sculpt. It's shaping. It's volume. So we use the word sculpt, but technically under the hood, it's just a blend shape, right? It's a vector-based offset. Now, if we think about everything you'd see in the human rig, in this case, I'm going to go here and hold the shift key and click, and it's going to expand everything out, right? There are thousands of different entries and inputs into here, right? If we look at this, right, all the different elements of control are here. And then this is something we're going to talk about over and over again, is the level of control. But with control becomes complexity. And with complexity, it can sometimes be difficult to find what you're looking for or work on the thing you want to work on. So we're trying to make that process easier inside our tools so that you can find and work on the things you want right from the beginning. And this is just a start. Our UI will evolve over time. But let's say I want to work on the jaw. I type in jaw and I get all of my jaw elements. If I do -A, it shows me my animation or my A bars, right? Now you can see that thousands of items I've turned it down into what I want to look at. Now this yellow here means that I've got an animation interface plugged into it. So in the case of a production pipeline, your animators have all of their elements. They're working on the controls they're working on. But when I'm rigging, I want to look at it right next to where my weights and where my fitting are. So we give you the ability to say, cool, I've got an input, but I want to override it. So in this case, I'll select this, right click, I'll enable my override, and now I can mung this channel and I can take over. What you see inside of this view here, let me go ahead and turn off the joints so they're just out of our way, right? Right. This value is the value going into the rig. So it doesn't matter if animators are doing whatever they're doing, you get ground truth in this value, right? So here's my jaw up and down. Now, if I wanted to play around with the fitting of this, I can go -F and it brings up all of my fitting elements that are based on the jaw. So I can select this and I can pull this fitting out. And what does that mean? That means this is the pivot of rotation for my jaw, and I want to dynamically edit that. So I go here and I say, pull it out. I've pulled it out. You see this little check mark here? I guess it's not a check mark. It's a pill. I don't even know what you call it. What's the UI term for that thing? But when we come here, you'll see that now we have a locator, right, that represents the rotation pivot of that jaw. And everything we're doing works live. So now, if we think about this, and Ozone is really good at giving this kind of relationship to an animator and a rigging artist, is that now an animator and rigger can work together and define the artistic characteristic of my jaw opening and closing, right? Live and together. So instead of doing work, sending it over the fence, animator does stuff, pushing it back, and you've got this crazy feedback loop, you can do it live in a session. You can be going, all right, does this feel right? Doesn't matter if the weighting is right or wrong. It's, does this pivot do what I want? Am I getting the character of the jaw in place? And it all runs live, right? And if you say, all right, cool, I want to go back to where I was, I can also discard that. So I can say, cool, we played around with this. We didn't really like it. So now I can discard that rig fitting, right? And it's going to go back. So now I'm back to where I was, right? We can also look at our weight maps. So let's go here and I'm going to grab the jaw UD, right? So let's toggle this, right? So now I can look at this weight map. And just like I showed in that other character, you can see that this weight map is fading all the way up into here. Now, this view of the weights is really just a way for you to diagnose and see where things are. You typically don't keep that up while you're doing your work. Now, if you're painting weights, which is a traditional Maya weight, obviously you're going to want to see those weights. It's not a problem. And you have all the standard weight tools that you're used to. But I'm going to show you a different way. We have a way of directly editing those points in a way that gives you, I think, much finer control over how a deformer's weight is applied. And typically, we like to think about weighting as modeling. We're actually modeling with deformers to create shapes. So, what does that look like? So I'm going to come in here. And let's go and edit this weight map. So I'm going to bring up the Mung tool. So what this allows me to do now is drag and adjust these weights. I'm literally going through and changing the values of these by directly selecting a vertex and adding or subtracting weight to its value, right? Now, I can come in here and I can smooth this. I've done a pretty ugly job of this. So let's go here and I can hit smooth. And now I'm smoothing this out. Let's go here and add a little bit more. I'm looking to make like a jowl shape out of this thing. So we'll go here and we'll smooth it, right? Everything stays live here. So as I come in here, I can see how this is pulling. Now look at here. This is where modeling with your weight maps is such a powerful idea, is now that I've got this basic, kind of grow. Let me frame it. Let me use some Maya tool here. But now I can come in here and I can just start modeling these bits. I can tune these guys out. And what I'm doing is I'm selecting with my left and I'm using my middle mouse to tighten and clean these lines up, right? I'm modeling with my deformer. I'm looking at these guys and I'm getting these shapes exactly where I want. It's precision, control. And this is a very big deal, not just for what I'm going to show you here in the rigging side, but on the animation side, right? Is that we give you a way to quickly set things up and then get down into the weeds and get precise results for the artistic goals that you have for your character. So I'm going to come in here and clean this up. And of course, at any time, I can grab these guys, right? And I can run a smooth operation, right? And tune these guys out and all this stuff stays live, right? I'm pulling things around. So just being able to directly edit these things in a way that's like modeling, I think it's a very big deal. Everything that we've done here on this side, right? I can take everything here and I can mirror it. So let's go in, take these guys, and then I can hit mirror and it will mirror over to the other side. Oh, it did already. Just so fast I didn't even notice it. I'll take it so fast I couldn't tell, right? So it mirrors it over. You can also make changes on one side. So let's say I want to mung these guys up and I don't like to move these guys as much as I'm moving them. And I'm going to take them and I'm going to smooth them, right? So we're going to go here. So I've made a change to the right. And let's say I like the right more than I like the left. I can grab this and I can mirror it back. So it mirror, and now it updated the left. So you can mirror from left to right. You can mirror from right to left based on your selection. So independent weight maps means that now if you look at this, and actually I'll show that in the next part. I'm going to show another character. So here is, as we go through and we've done the mirroring, now we can do a sculpt. So let's do that, right? So I'm going to select this, turn off my Mung tool. And now I'm going to look at sculpts. So I do -S, it brings out my sculpts. And I'm already, there's a whole lot of stuff here. So what I'm going to do is I'm going to add a UD here. So it filters only to where I have UD, right? And let's say I didn't want to see LT or RT, I can come in here and use the bang LT, and I can do bang RT. And now I've tuned this out. I'm seeing my one locator for my fitting. I'm seeing my one AVAR for my animation, my one weight map, and just the two sculpts I want to look at. So this filter field is a great way to help find what you're doing. Now, if you want to say, I don't want to have to run this filter every time, I can go here, select everything, right click, and say add to my scratch panel. This is a temporary view of anything you want. So now you can find the elements, the weights, the sculpts, the AVARs, whatever you're looking to do, and just dump them into the scratch panel. And it becomes like a session view of what you're working on. So now I can come here and I can turn all that off. I can see everything, but I can always come back into my scratch panel here and I can adjust these guys live, right? So now let's go here and I want to add a sculpt. So I'm going to grab this. I'm going to grab my positive sculpt, which is the value that I've gotten here. All right, so let's go here and grab this. So I'm going to pull my sculpt. So now, just like we did when we pulled the fitting, right? We pulled the element out. Here, I'm actually going to create a copy of my model that allows you to make whatever modeling change you want. It's just standard Maya modeling at this point. You can take that model, push it into ZBrush, do ZBrush sculpting, bring it into Modo, wherever you want, bring it back in, and then apply it. In this case, we're just going to do it here, but I'm going to pull the sculpt. And what it does now is it's made a copy of that file. Right. And now I can do something, and I'll do something that's, ugly. We'll grab these guys out and I'll pull this out like this, right? Not the prettiest modeling job in the world. But then I'll hit push. Now what it's going to do is it's going to figure out how do I get the points to end up in that position, even though I've rotated my jaw, because the sculpt is actually executing before the rotation. So you end up with a pre-fired sculpt is what we call it. It's executing, then it's putting its points where it needs to be, and then the rotation pulls it where it needs to go. What this means is that you're never going to see a linear move from a sculpt blend shape anywhere on an ozone face. Everything moves in an arc. Everything moves through space in a non-linear way. And we can kind of look at this, me open up my view here. All right. So here you can see where, it's kind of happening. Now, because we're dealing with an ozone, it's a sculpt vector, right? Math hat on, right? It's just an offset in a position. Those vectors are math operations, right? Or can be affected by math operations. And what does that mean practically? Well, you saw how I smoothed weights. Well, I can come here now, kind of increase that, and then I can run my smooth command, and it will actually smooth that sculpt, right? This field here, I can actually go and set a number. So in this case, I'm using my little scroll wheel. I'm going 1.5, and now I can increase the magnitude of that sculpt. And then I can expand it out, and then I can smooth it again, right? Right, and I can say, well, that's great. It's smooth, but it's moving too much. Again, you can look at this, right, and see how it's pulling around. Well, I can come down here, make this 0.9, and I can multiply against it. And I say, oh, I want to shrink this out, and maybe I want to shrink it faster. So I'll go 0.5. Now it's 70% every time I hit that button, right? So I'm able to add that to it. And if I want, I can mirror it, and it'll push it over to the right. And now I've got this left and right. Right. And let's say I want to come in here and say I want to take that sculpt out. I can select my sculpt. I can go here, double click, make it 0, and hit equals, and it will subtract the vectors completely away because they're just a mathematical expression. They're a magnitude. Now, from an artist, you never have to think about this. You pull it, you make a shape, you push it, and it works. But what's nice is now that all the same tools you'll use for your weighting, you can use for your sculpts, right? I'll go ahead and mirror this over and take it away on the other side. And of course, it doesn't do it because it's a live demo and it worked a second ago. But that is how this works. I can also come in here and I can equal 0 and it goes away, right? So these sculpts are editable by math. So now let's look at a brow, right? So I'm going to come in here and let's go ahead and hide this. So same idea with the fitting. We're going to come here. Let's go ahead, right click, and I'm going to clear the scratch panel. And now I'm going to look at my browse. So let's go brow, UD, all. I'm going to grab these two guys. I'm going to add into my scratch panel. I'm going to do brow UD, weight. I'm going, actually, no, I want to use my fitting, right? I'm going to grab my fitting, and you can see I've got actually a positive and a negative. I'll add these to my scratch panel, and I'm going to add -D, which is a default value, right? And we'll explain what that is. So I'm going to right click, add to my scratch panel. Okay, so now I'm going to grab these, right click and enable my overrides, and I can look at bringing my brow up and down. And like we talked about in that other example, right, the brow up and down is actually sliding along a curve. That's what this is. So I'm going to go ahead and pull that fitting out. So I'm going to pull this fitting, and you see that we get a curve. And if I pull these guys up, now I can grab in here and edit this, right? And I get a live adjustment. I get to see how these brows are moving along this curve in real time. Again, imagine working with an animator or animator working with your rigging artist to tune the feel of something. You know, hey, here's what I want this to do. And you go, all right, cool, but I wanted to do that at 100 because that's what I expect my extent to be. I go into my, what we call a scale factor, and I can adjust what 100 is for my animators. So now you have complete artistic control over where something moves, how it moves, and how fast it moves, right? And everything is its own idea. What I'm doing with the brow has not broken a single thing on the lids, didn't break anything on the jaw or the mouth, right? So tons and tons of control that isn't so painful to give. You know, it's a real win there. So anyway, that's here. Let me fire up what you guys maybe answer some questions. I'm going to fire up another session and show pork chop.
Perfect timing. We got, just so you remind you, Rich, we got 6 minutes.
Oh, we're gonna run long.
But I'm excited, and it's so funny. One of the Rodney I got to call out was giving you some tips on Maya in your
I need him because
selection.
I'm not a Maya guy.
And I was reminded, Rich is not his Maya, not his first love.
It is not.
So,
I
but
spent
you
13 years at
so,
Pixar using proprietary software. I spent a year and a half down at Rhythm and Hughes learning that. I worked in Moto, and it's not my first thing. But oh, Brad, sorry, you talk. Oh,
Brad,
you raised your hand, and then you went
There we
away.
go. I was just gonna say, yeah, the selection tool option for munging weights. I think I think that's the having more selection in that tool right now is gonna be, we have a lot of things to improve on just the interaction with selection, but the actual interactivity of selecting and adjusting the weight values directly it beats the Maya spreadsheet editor. So we'll put up with some selection quirks until we don't have to edit the selection and spreadsheet. So
Yeah. Well, I think a good, just for everyone listening, is we're just getting started, which means as soon as more people are in there using it, we're going to get more feedback and we're going to tighten things down to make the best possible tool for you guys. So it's like, this is the beginning of this journey. You know, nobody has any muscle memory yet. We're figuring out best practices, and we have a very, very important point of view at the company, which is the best idea has to win, right? Now it's like trying to make a movie. If you have 10,000 people giving you 10,000 opinions, you don't get a movie made. But the fact is, we're going to listen. And if we get enough people are saying, hey, we need something to work this way for this reason, we're going to listen, because we know what it's like to be in the real world doing real production. All of us do. So we want to make this be as streamlined, as easy for you to use as possible within the context of how we're trying to solve the problem. So I love it. Any opinion, any kind of thing, we will take your feedback. It's important. So
yeah. Hey, while that boots up,
I'm ready
Rich,
if you want to answer a question, I'm ready whenever you are.
All right, jump in. There's one more question I thought would be good to answer.
Go for it.
And it comes from Eugene, if you don't mind. Are those deformer curves part of the Ozone file? Do they transfer over relative to other characters if they share the same topology?
100% yes. So the way it works is the curve is defined in the rig. So you have a curve for up and down, you have a curve for left and right, fitting elements, and that all lives in the rig. So if you think about the way Ozone looks at a face rig, it is a combination of weights on points and spatial deformers. They're separated and coupled. So that means that all of those curves can be transferred. That entire rig and the way it's set up can be moved over to another character. If you have the same topology, and I say this is a right now limitation, then you can transfer all the weights over, regardless of the shape, and you end up with a character that's got all of that, all of those deformers set up, working and fit, and you get a starting point that's close to 80% right for free. We are working on some tools to be able to transfer weights from one mesh to another, ingest topology changes, all that's coming. Right now, though, if you use the same topology, you can transfer an entire amount of rigging from one character to the next, and then just refit and readjust the curves on it. Now, if you didn't have the topology, you can reuse the rigs and the fitting and everything. You would just have to do the weight maps again right now if the topology's changed. But hopefully that
All
answers
right.
your question.
Well, nice, Rich. Bring us home, man.
All right.
Yeah.
So we'll look at this again. So here is a character that we're developing with the fine folks at the Henson Digital Creature Shop. So what I'm going to show here, what I want to kind of explain is looking at how you can have different weight maps for different axes of rotation in a practical way. And then we're going to look at how different actions can have different weight maps for very precise control. So let's just look at this, right? So if I go here, right, and I open or pull this up and down, right? This is, an elbow up and down, but the twist, of course, is separate. It's a separate weight. You notice how simple the skeleton is, right? Let me open up this, right? So right away, just thinking about how these guys work, right? The elbow does whatever it's going to do, and that's independent of what the wrist does. It's independent of what the shoulder does. So let's look at the arm rig, and we'll look at some of these weights, right? So to bring this home, you have, right, this is the arm weight. And what it does is you're blending things here, and it just takes the results of the wrist and the elbow. If I look at my elbow weight, this is my elbow weight. If I look at my wrist weighting, that's my wrist weight. So the wrist will execute and do its thing. The elbow will take the result of the wrist and do whatever it's going to do. And the shoulder, in this case, the arm, will do what it's going to do. What that gives you, that freedom is that if I make a change to my elbow, I'm not affecting my wrist and I'm not affecting my shoulder. You can now focus on the area you want to work on. But even, kind of more importantly than that is my up and down and my left and right are different than my twist. I have a different weight for my twist. So when I'm pulling this, and I'm making these shapes, right? And this is a combination of a weight map and a sculpt, right? When I'm pulling these guys, they're different. I'm not fighting against myself to make my twist work right versus my up and down, right? So let's just make a change here, right? So let's say I want to change the sculpt of this, right? Well, first of all, how do I even know there is a sculpt? And I do because I did it. But how do you look at this and see? Well, let's say let's pull this up and down. Now what I can do, and let's do some filtering, right? So I'm going to grab this. We'll grab our sculpts down here, and we'll just grab these guys, and we'll move them to our scratch panel, right? So if I look at this is my sculpt. This little pill here, I can turn it on and off. So I can look at what this looks like. This is the raw weighting, and this is added my sculpt, right? I mean, and you think about rotation and rotational weighting, right? Things always kind of balloon because you're pulling it along an arc, but you can see how this is, how it affects you. You can also turn off the weight itself and just look at what this sculpt is doing, right? This is what the sculpt needs to be when it executes beforehand to get to this shape when the rotation happens. But you never have to think about that. That's just the technical under the hood. What you get to think about is that when I adjust this, nothing is ballooning around. I'm not fighting against this. I'm hitting the shape, and you can see things are sliding in the right direction. They're moving down with the elbow correctly. And if I want to make a change to this, I grab my sculpt here and I pull it. So I'm going to pull the sculpt, and let's just, I'll do something small here. Turn this around so I can go. So I'm going to I'm going to grab these guys and we'll do this and we'll go here. I mean, I'm not doing anything fancy. I'm just making something look a little prettier, right? So now I've changed this. And yes, I'm sure there's some Maya tools I could be using for selection and whatever that would make my life easier. But right, I'm trying to clean up this shape and get what I want out of it. Cool. Got this. Now I'm going to go ahead and I'm going to push my sculpt, push it in. It'll update, basically does that inversion of the shapes. Now I'm good to go. And I can look at how that works live, right? I'm just going to look at how, right, how that stuff's moving, right? It's a very fast workflow. And I didn't have to worry about how, when I'm doing my up and down, how it's affecting my twist. And if I want to affect my twist, I can. So let's go here. I'm going to grab my twist weighting. I'm going to grab my Hmong weights, and I'm just going to grab these points, and I'm going to tweak it. So I can say, hey, I want the twist to happen a little further down the arm and not be so wrist centric. I'm just going to go through and I'm going to make this change. And everything I'm doing here, I'm not affecting my up and down of that elbow at all. I'm only affecting the twist, right? So now I can look at this, right? And you can see that now the twist is happening further down the arm. Not super appealing, but the fact is I did that and I didn't change anything about what's going on my elbow. So fundamentally, just how this system works is makes your life as a rigging artist better, makes it easier for animators to give you a note about something without hours and hours of reworking. It doesn't mean they can't, because animators have a certain gift that way. But the fact is, it doesn't mean every single time you get a note, it's going to send you down that pain rabbit hole. Okay, so one last thing, and then I know we're running over, but let's take a look at having the same control. In this case, I'm going to do here. Let's just show you. So I'm going to do my mouth avars. I'm going to look at my mouth main. So let's grab these guys. I'm going to add them to my scratch panel. Let's go ahead and remove these because I don't need them anymore. And let's do the weight. So I'm going to grab this guy and this guy and this guy and this guy out of my scratch panel. Okay. So now let's take a look at this. So if I look at the mouth UD, what this is doing is it's taking the whole mouth and it's moving it up and down, right? And my FB is going to move my mouth up and down, right? Now, right now, it's using the same exact weight map, right? What I have, I mean, I guess it's slightly different, right? So that's my positive, that's my, so I guess they are different. But let's make them really different. And more importantly than that, let's look at what we can do from a positive and negative standpoint, right? So right now, if I move this positive versus I move this negative, right? You can see how it's tugging on the nose here, but maybe when the mouth is going into the negative, right? And I'm moving this down instead of up, right? I'm going down here. Maybe I want to tug the nose a little bit more for whatever facial expression my animator's trying to get. Well, I have negative weights now. So I can come in here and I can come in and I can say, all right, I'm going to grab these points and among them, and I'm going to tell them to move a little further, right? Come on, you should do that. There we go. Right. So now I can pull this a little more, and I don't have to get any fancier than this, right? Right. I can pull this here, and then I can come in here and I can smooth that weight. Maybe I can mung it a little bit more. But now, right, as I go down, and you can see, all right, I've got a race condition, if you will. I can tune this out a little bit. We'll come in there. But you can see that as I'm pulling this, right? But when I go across 0, you'll see that it stops. Now I can have a different weighting for a different direction, right? My positive versus my negative. Think about this from like mouth and lips moving forward versus left and right, up and down, and how it tugs on the nose, how it affects the chin. Now you're not fighting against a single joint. It has one weight, and you're this crazy contraption under the hood that's pushing stuff around. You can think about each idea as each idea independently, and each weight map independently, each direction independently, and they all play nicely together. They all add up. And then kind of to bring this home, let's just say I want my FB to have a different weight map So I'm going to say, hey, I don't want this stuff. So I'm going to grab here and we'll go here and let's grab here. Yeah, you guys can pick on me about my Maya. So I'm going to come to this. This is my FB pause. I'm going to go here, hit this to 0 and go done. So now when I'm moving this, it's not moving this. You can see these guys over here doing stuff that I don't want. So come on, Maya, what are you doing? Yes, I know, not a Maya guy. What are you gonna do? So we'll equal 0, right? But now my FB, my positive blip is doing something different. It's completely different than my forward and backward. And if I wanted to, I could come in here and I could grab all of these points and say, yeah, I want to go back to what I had. So I'm going to go to my UD pause here. I'm going to copy it and I'll go to my FB pop and I'll paste it. And I brought myself back to where I was. So anyway, that's what we're going to cover today. But the real takeaways I hope everyone is seeing is the level of control you have as a rigging artist with this system to be able to deliver shapes and put them on screen. And we're going to go into a whole lot of how best practices and everything else, but that is the demo.
Right on. Well, thanks, Rich. Brad, thank you guys both for joining the webinar today. We are a few minutes over, but we had some computer ups and downs, and so it's okay. Hey, we'll be sending out not only a beta update for those who are asking, but also an update on our next webinar topic and what we plan to copy. I heard some Houdini rumblings. I heard some all different types of things. So be on the lookout for that as we get ready to send it out. But Rich, I'll give you the final word to say goodbye, and then.
No, man, I just appreciate everybody that
Yeah.
came to watch. Again, be looking out. We're going to be doing more and more of these over the next 6 to 12 months, to be totally honest. We want you guys to know how to use this, but also learn the best practices and see how it all connects up together. So thank you for attending.
Right on. All right, guys. Later.